Welcome to Mr. Academia YouTube channel. Remember to subscribe, get notifications for all our lessons, share our lessons, like, and also comment on our lessons. We are going to look at matrices today, and remember to contact us at this. These are contacts here, such that you can have book lessons at your own wish and at your own time. Uh, by the end of this lesson, you should be able to display information in form of a matrix and also determine the order of the matrix, calculate products of matrices, and also multiply matrix with a scalar, add, subtract, and multiply matrices to, and also use zero and identity matrices. If you look at what a matrix is is singular, whereas when there are many, we call them matrices. A matrix is also defined as a rectangular array of elements which are always arranged in what we call rows and also columns. And of course, we have brackets uh, that enclose the elements that are arranged in rows and columns. For example, if you look at these are the brackets here that are enclosing these elements here. This is another example, and this is also another example of a matrix. An order of a matrix, of course, when writing order, what we call dimensions of a matrix, we write them in terms of rows and columns. That is, we use this notation here, rows multiplied by columns, which we read rows by columns. So the rows are horizontal lines of entries of elements, whereas the columns are vertical lines of entries of columns, as we shall be seeing. For example, if you look at this matrix here, uh, this is the first horizontal arrangement of elements, the second and the third. So meaning that this is the first row, this is the second row, and this is the third row. Then the vertical arrangement of elements is this and this. So this is the first column, and this is the second column. So that means that this matrix here has 3 rows and it also has 2 columns. So its order or dimension is a 3 by 2 matrix. So this one here is read as a 3 by 2 matrix. If you're asked to write down the order of the following matrices, for example, the first one here, this one here has 1 row, and then 1, 2, 3, 4. It has 4 columns, so this is a 1 by 4 matrix. This one here has 2 rows and 1 column, so it's a 2 by 1 matrix. So this is a 2 by 2 matrix, whereas this one here is a 3 by 3 matrix. A matrix with only 1 row is what we call a row matrix. Then if a matrix has 1 column, we call it a column matrix. So we always use capital letters to represent matrices. For example, you can see this D is capital. In some textbooks, they use bolded letters, but for us, we shall use capital letters when representing a matrix. Look at addition and subtraction of matrices. For any 2 matrices to be added or subtracted, they must be having the same order. That is, if one matrix is a 2 by 1, also the other one must be a 2 by 1 matrix. So the corresponding elements and entries of the 2 matrices are added and subtracted together, as we shall be seeing in our example here. Like how we have matrices A, B, and C. So this is matrix A, which is a 2 by 2 matrix. Matrix B is also a 2 by 2 matrix. And matrix C is also a 2 by 2 matrix. So since all these matrices have the same order, so it means that we can add and subtract each of these 2 matrices because they all have the same order. So meaning that we can look for A plus B, B minus C, and C plus A. So A plus B, we add corresponding elements, like we have a 2 here. It occupies the same position with a 1, so that's why we add 2 plus 1. Then the 9 and the 3, they occupy same positions in the different matrices, so we add them. So the 1 with the 7, this and this, then 3 with the 4 to give us this and this, and the answer is this. So we do the same with B minus C. We subtract elements which are corresponding in positions in the different matrices. 1 with the 1, subtract 3 minus 0, 7 minus 0, negative 4 minus 1, such that our answer is this one here. So we do the same when we add C plus A to get our answer as this one here. So you can perform these calculations here and see what you get out of these calculations as a test yourself to know whether you've picked up the concept of matrix addition and subtraction properly. Looking at matrix multiplication, we first deal with what we call a scalar. So a scalar is any number ranging from 1 or 0 or any number we use k to represent a scalar quantity. And the matrix, if we know that which side is represented by capital letter, so meaning that the matrix times the scalar, we shall represent it by K multiplied by A. So in this case, when we are multiplying a scalar quantity to any matrix, every entry in a matrix A is multiplied by that scalar, which is multiplying to the matrix. For example, here, if you are multiplying -1 into the matrix A, where the matrix A is this one here, so the -1 here will multiply with each of these elements of the matrix, as you can see here. So -1 into this matrix. So -1 will multiply with -1 to give 1, -1 times 2 to give -2, -1 times 3 to give -3. But each of these elements in this matrix multiplies with this scalar, which is -1, and end up having our answer as this one here. If we multiply matrices now, for matrix multiplication, that is when you are multiplying a matrix with another matrix, the number of columns in the first matrix should be equal to the number of rows in the second matrix. The number of columns in the first matrix should be equal to the number of rows in the second matrix. So if we look at this, so we also have to look at the idea of row and column matrix. So in order to understand the general procedure of matrix multiplication, this idea here is very, very important, especially when we're dealing with the idea of a row and a column matrix. Row by column multiplication. So if we have a 1 by 4 row matrix, this one should it has to be multiplied with a 4 by 1 matrix. You can see that the number of columns in the first matrix is equal to the number of rows in the second matrix. So meaning that these two matrices can be multiplied and the answer will be a 1 by 1 matrix. So you can notice how we are doing this. So when we are multiplying, we multiply a row with a column. So meaning that the 1 will multiply with a 5, and this will be 1 times 5. A dot here means we are multiplying. 2 with a 6, that is 2 times 6. 3 with a 7, 3 times 7. Then 4 with a 8, that is 4 times 8. So we add up the results that we get after multiplying each row with a column, and the answer will be 70, as you can see here. So let's look at now what if we have two other matrices, that is the matrix A and B, as you can see here. So this is the matrix A and this is the matrix B. So if you have to look at the order of this matrix, this is a 2 by 3 matrix and this is a 3 by 2 matrix. So meaning that these two can be multiplied. This is the number of columns in this one is equal to the number of rows of the matrix B. So when we are multiplying, we multiply a row with a column, a row with a column, as we shall be seeing in our next slide in the solution. So since A is a 2 by 3 matrix and B is a 3 by 2 matrix, AB will be a 2 by 2 matrix. So we multiply the first row of A by the first column of B, that is, we multiply this, the one which is in red. So that will be 3 times 1, 1 times 3, and -2 times this to give us 8. The first row of A times the second column, so this times this, and this is the one which is in green, which is here, and this gives us the answer here. So we proceed, we multiply this and this to give us the answer here, and then we multiply this row with this column to give us the answer which is here, and that is how we end up coming to the final result, or what we call the final answer of our question. I perform the following matrices here to make sure that you have understood everything that we've talked about. So you can make this as a trial of your own, pause a bit and multiply this. If you look at the determinant of a matrix now, every square matrix has what we call a determinant, and determinant can only be determined from a square matrix. So the determinant of a matrix is a number, and we will consider in this case the determinant of a 2 by 2 matrix, and we always use the formula the multiples of the major diagonal minus the multiples of the minor diagonal. So the determinant is always important, especially when we are calculating the inverse of a matrix, and it is used when finding the area of a triangle. So let's look at an example where we find the determinant of a matrix. So first of all, notice in this matrix here, the straight lines will tell us how to find the determinant of this matrix here. So of course, the determinant of this matrix, we find the product of elements along the major diagonal minus the product of elements along the minor diagonal. So the major diagonal is this one that runs from here to here, and then the minor diagonal runs from here to here. So we are going to get the product of the major diagonal, that will be 3 times 4, and then we subtract the product of the minor diagonal, that is negative 5 times 2, as you are seeing here. So 3 times 4, that is the major diagonal, and then we subtract the product of the elements on the minor diagonal, that is negative 5 times 2, such that we end up with 12 minus negative 10, and then our determinant is equivalent to 22. We have what we call an identity matrix. So an identity matrix is a square matrix with ones on the diagonal and zeros everywhere else. So it has ones on the diagonals, that is 1 on the major diagonal actually, and then zeros elsewhere. For example, if you look at this matrix here, this is an identity matrix. It has ones on the major diagonal and then zeros everywhere. If it is a 3 by 3 identity matrix, you can see the ones along the major diagonal and then the zeros elsewhere. So that is a 3 by 3 identity matrix. So every time you multiply a matrix with an identity matrix, you get that same matrix. That is, the matrix is not changed when you multiply it with an identity matrix. You can see if you multiply this times identity matrix, you get the same matrix. So even if you change the position of the identity matrix, you still get the same matrix. So identity matrix multiplied by any matrix, that matrix keeps its shape or it doesn't change. So meaning that this is similar to this, or a matrix not change by multiplying it with an identity matrix. If you look at the inverse of a matrix, so the inverse of a matrix, we are going basically to look at a 2 by 2 matrix. For example, matrix A here. So we always need to find first the determinant of a matrix before finding its inverse. So the inverse is got by using the formula. The inverse of a matrix is 1 out of determinant. So you realize that this is the determinant because AD is the major diagonal and CD, those are multiples of elements on the minor diagonal. So this is the determinant. So it's 1 over determinant multiplied by what we call the partial inverse of the matrix. So the partial inverse of a matrix here, it's got by switching A and D. So you can see that A and D are switched, and then we change the signs of B and C to get what we call the partial inverse, as you can see there. So let's look at an example of finding the inverse of a matrix. So we are supposed to find the inverse of this matrix here. So first of all, we find its determinant. So the determinant, we multiply this and then we subtract those. So the inverse will be equivalent 1 out of 2 times 10 minus negative 4 times that. And then we change this, and then we change the signs of this and this, which gives us this matrix here. So go ahead, perform the calculations. We end up with the inverse of this matrix as being equivalent to this, because the determinant is negative 4. So we now feed in the 1 out of negative 4 into this matrix, and we end up having the inverse of this matrix as this one here. So that is how we find the inverse of a matrix. Even if it is this one, the general formula is 1 over determinant times the partial inverse. The determinant is got by this minus this product here, which is this one here, and is 1. And we go ahead and get the inverse. You can see the 8 and the 2 are interchanged, and then the signs of this and this are changed, such that the answer is that one. So what happens when you multiply a matrix by its inverse? Let's look at this. For example, if you multiply this matrix here with its inverse, let's see what happens. I'll end up getting an identity matrix. So every time you multiply a matrix with its inverse, you get what we call an identity matrix. It's very true. A matrix times its inverse gives an identity matrix. We can also solve simultaneous equations using matrices. You can take a system of equations and write it with matrices, as you can see here. We are having an example where we're supposed to solve these two equations using matrices. So first of all, we write the equation in matrix form. That is, we arrange the coefficients here, those of x and those of y in matrix form. So you can see the ones of x are occupying this column and the ones of y are occupying this column. So if the equation is not rearranged, you have to first rearrange the equation such that the x and y coefficients occupy the same positions, and then these other constants also occupy the same position. So meaning that in matrix form, this is how it is written. This is for the coefficients of the matrix, and this is for the variables, that is the x and y, and these are the constants. So next thing, after rearranging the equation in matrix form, we find what we call the inverse of this matrix of coefficients. Find the inverse of the matrix of coefficients, and then we multiply it on both sides. We studied, or we looked at how we find the inverse of a matrix. So we find the inverse of this matrix and then we multiply it on both sides. That is on this side and on this other side of the equal signs. So the inverse, that is how it is being got. You can see how we are finding the inverse of a matrix, which is this one, matrix of coefficients. So after getting the inverse, which is this one here, we are now going to multiply it on both sides. So multiply it here with this one here, and that is what we get. And also on the right hand side of equal signs, that is what we get. So finally, of course, this matrix times its inverse, we get an identity matrix. As you can see here, we are having an identity matrix which is multiplied into the variables, and then we look at the answer we get on the right hand side, which is that one. So finally, if you multiply this identity matrix with the variables, we end up having x and y, and then on the right hand side we get 5 and -2, like that. So finally, you can conclude the value of x and y as x equals 5 and y equals -2 from this one here. You can conclude x equals 5 and y equals -2, which are the answers that are written down here. So if you want, you can go ahead and check, substitute x and y in this equation and see what you get. I'm sure it still gives you the same thing, meaning that it has worked very well, and that is the solution. So you can try out this and see what you get out of this equation. I'm sure you're going to find out that it is the best, and the answers are here. You can check and see whether what you've got corresponds with what we have as our answers here. Uh, Thank you for watching our video. Remember to subscribe to our channel, like, share, and also comment on our lessons to enjoy the best out of our lessons.